Okay, today I'll be showing you how to create a Flappy Bird game using uNode Visual Scripting. Let's get started, shall we? First off, to make a graph, we're going to go to Tools, uNode, Create New Graph. For this specific tutorial, we're going to specify that we need to use a runtime graph so we can edit this on the go. Let's quickly create one. I've already prepared some stuff in advance, graphs, tutorials, and then let's call this, let me think here, Bird Controller. Okay, once it's created, we can simply go to our project view and drag and drop it onto the bird. I've already set up these things in advance: a rigid body 2D, a capsule collider 2D, and an animator with sprite renderer. Let's edit this graph. Okay. First of all, we're going to need some variables here first. Let me think. So there's two variables at the beginning, two floats. Let us call this the velocity. Let's set it to default to be 2. Just going to duplicate this and call this rotation speed. Let's make this, I don't know, 8? I don't know. We're going to set in both the private and serialized fields. This is just to expose them in the inspector so we can edit them without having to see them in the code. You'll see what I mean just now. Okay, let's also make a rigid body 2D. Got this. This is a rigid body 2D. Okay. Okay, now let's go to the start method, and we just get this component from the same game object we attached the script to. We type in here get component t rigid body 2D. Okay, since we're working with physics here, we're going to need fixed update as well. And on update, I'm not going to use the new input system now. Let's just do this with the old input system, just to simplify things. Okay, so if input.mouse get mouse button, yeah, there should be mouse 0, plug it into the if, organize it. And then we drag out the rigid body, and rigid body velocity. I'm using UT6. In UT6, this is going to be called linear velocity instead of just velocity. Linear velocity, and just basically set this. Whenever we press the mouse button, we want the bird to fly up. So now I'm going to think, so we can use vector 2 dot up, and then we're going to have to multiply it with our velocity. Plug it in there. Vector 2 up, multiply with the velocity. Yeah, let's do it like this. Yeah, this can work. Okay, so this is basically what we need to do an update to get our inputs. And fixed update, we're just gonna have to do transform dot rotation. I'm just gonna say this game object. You can leave the this here, but I just like doing it like this, is a bit more cleaner. The base game object, transform dot rotation, and then we have to set it again. Gonna have to do Euler. Quaternion.Euler. Get this floats. Okay, everyone. Since this is 2D, we don't have to work with the Y here. So we can just work on the Z axis. So rigid body velocity is a linear velocity. Multiply by our rotation speed. I've made a big mistake here quickly. So we're now going to do uNode vector free or whatever, close enough. Just plug it in like this. This automatically converts us to a vector free. And this should what we need for the bird. Okay, so now if I press play, you can see the bird starts flying. Might need to change the gravity scale a bit. Yeah, the gravity is way too low. Gravity scale 1, let's see. Now this might be a bit too difficult. 5. Yeah. That should work for now. First of all, we need to put in some extra stuff for like the pipes, like we usually do in Flappy Bird. So let's go to the sprites that are already imported. Let's find the pipes. Let's just call this pipes. And let's find it. I forgot to make the project in 2D, so apologies for that. Look it up. Just like this. We make it scale this puppy a bit down. See what it looks like here. So I've seen. Oh yeah. Move it a bit down. Still a bit too big. Let's do. Scale it just like this. Make another one. So there's at least 2 of them. Now. Let's empty game object. Let's call this pipe holder. Select him and drag him in here. We also need to give them some box colliders. Make sure it's box collider 2D. Just make sure just a little bit. Need to do it with the background as well. So let's do 2. Yeah, 2 should be fine for these. Okay. Take this first one. What am I doing? Apologies. Okay, 180. Okay, this should work for now. Let's save the scene. Okay, let us make a pipe spawner. And yeah, I'm live there. Okay, so pipe spawner. Okay, let's go to the uNode runtime graph again. The graph, class definition, graphs, tutorials, pipe spawner. Okay. You're going to need 2 floats. Next time. And this other one, height, rain. Max time, let's make it like 2. Okay, let us also, think because we got the pipes. Oh yeah, we need to put the actual script on it. There we go. Expose the speed variable here for us. If we go to the bird, we don't want to change our velocity, so rotation speed, rigid body, yeah, everything should be fine there for now. If you want to override it, just stick there and you can specify like drag the rigid body in here for now. But we've already done this basically in the script. Okay, let us test. Okay, basically it was nice. Now we're going to have to instantiate these prefabs so they continuously spawn. I'm going to have to think about this one for a moment. Okay, so I thought about it. So we're going to need keep the update and start methods. You're also going to need spawn in the game object here. So it's for like our actual pipe. This is going to be our prefab that we're going to spawn in. Also, we're going to need a timer since we want to spawn it every single certain amount of seconds after it has passed. Let's do like timer. Make it private. Serialized field. Serialized field and private. Private. Serialized fields. Actually, we don't need serialized field in this one. We're just going to keep it private. You want this public? Yeah. So on start, let's just create a new method called spawn pipe. Pipe. Drag it into our start method so it calls it when we start. Okay. And update. We're going to need to use our timer. Let me go a bit full screen here. If our timer is greater than our max time, then we set the timer to equals 0, and then we spawn the pipe. And we want to increment the timer on update. So if we drag out the timer again, and on the exit of the if, we do plus equals here again, so it counts up every single frame with time.delta time. Time.delta time. Perfect. Then we can go to spawn pipe. Okay. I'm going to show you two methods here. Either a local variable that we can make over here, or we can just make it a cached variable, which would look a bit cleaner anyway. So let us call from finger. So we want a spawn position. So let me do the local variable one first. Okay. Spawn position. And drag this out. I want to set the spawn position. Okay. If you look at the C# code now, you can see we have to do it like that. Spawn position equals vector 3.0. So now we're going to have to feed this logic in order to spawn this at a random range along the height. So let's do transform dot position. Transform dot position, and then we're going to have to add vector 3, a new vector 3. We want this to happen on the Y. So we're going to have to do random dot range on the we want this to be a float. Yeah, I want this to be a float. We're dragging the height range for the maximum, and to inverse this, basically we can do this at negate this value so it goes into opposite for the minimum. And after that we add it. So yeah, then that should be it, I think, for the spawning like that. Not for the spawning, for the position at least. And let's create a new game object local variable. The pipe that's being spawned. Drag this out and do set. I'll make some space over here for us. Okay, then we do instantiate. Okay, let's think here. So instantiate the original. We're gonna need this position and just a rotation. We don't need the actual parent. Yeah, so position and rotation. Yeah, we can do it like that. Click on the node that I just created, which is object, just the game object. So we specify what we want to spawn in, refresh it, and then we plug it into the pipe spawn. Also, we now need to drag in our original prefab pipe variable. We're going to make this a prefab, which is now the actual pipe we made earlier in the scene view. And for the spawn position, we're just going to use our local variable that we've made here, plug it in here. And for this, we're just going to do quaternion.identity. Okay. We also want to get rid of these pipes after they spawn after a while. Let us just do destroy object and float. Now it's going to give us this node here, the object destroy. So we want to take our pipe that we've made in the local variable tab, get it, plug it in here, and we want to destroy it after, let's say, 10 seconds. Okay, let's quickly see if I let go now. Pipe spawner. I'm going to drag the pipe spawner on here. Okay, and let's make this a prefab. Don't worry about these two over here. That's just for my own testing purposes. Then we go to the pipe holder, make the prefab. We go to the pipe spawner. We want to specify our game object variable that we've made. We drag it in like this. Our height range, let's make it like 0.5. Yeah, let's test. Let me just quickly take out this here since it's now prefab. And let's take a look in the uNode inspector so it can actually start spawning us. So if I press play. Yeah, spawned it, nice. After not the intended way of doing it, but close enough. And we see how I can fix those pipes quickly. Okay, we also want to make a new script now, like a new class component object. So tools, uNode, create new graph, runtime class definition, save it. Let's go to graphs again, tutorials. Let's make this pipe mover. Okay, so let's think here quickly. So we're going to need a CLI shield for actual speed for the pipes to move at. Let's make it a float. Forward speed. Make it like 1. Just do 1. Private CLI fields. Okay, and update. We got as a transform.position. Transform.position. Once again, doing my simple trick just to make it a bit more efficient. And then we set the position. And here's another thing that comes in with uNode that makes it different from other visual scripting tools. If I maximize this now and go to the set value tab here, inspector, you can change this from equals to add equals. So this will make our life a bit easier without having to do redundant code. So if I do now vector 3.left and multiply it with a float, we're going to multiply it with our speed. And then multiply it with another float, time dot delta time. This is just to make sure it's not frame rate dependent. It always moves in the exact same speed. This should do it. Forgot to mention, we can have to also tick auto tiling as well on these box activities for the pipes, just on the prefab that you just made. Raw mode, let's just do a tiled. Well, okay. So if I drag this up now, yeah, now it's going to tile correctly. There we go. That's what we were missing. So let's make these just a slightly bit longer. This one, the exact same one for this one. Okay, let us test quickly. I didn't mean to spawn like over there. It's so fast. So the spawn position. The spawn position is calculated. Body game up. Okay, yeah, we just need to change the game object's position. Do it like this. That might have been a bit too far, but yeah, now it's working as intended. Fuck. Okay. Okay, let us now create a canvas. We're going to need to do the UI for now. So UI, and then our canvas. It will automatically add the event system for us. So we want this to be the game over canvas. And we're going to have to scale it with screen size. Okay. Okay, so let me think here. So we're going to need 3 empty game objects. The title. We want the game over screen. And then play button to replay the level. Just, I don't know why I'm not using shortcuts today, so bear with me. And play again. Okay. Okay, so we're gonna have to add images onto these as well. So image to each of them. Image. Image. Okay. Now let's go back and let's go to our sprites. We want the title to be. Okay, we want the game over to be here. So game over. This might be problematic since it's split into 2 here, so I might need to do it like this. Title. Move the image from the title here. Let's call this game text over text. You move them up, see where they are in the world. Move them up. Right, set the number 3 on the order and layer. Let's quickly organize this a bit better. Minus 400. Minus 401. Put down. Minus 702, okay. Minus 702. And let's drag it this bit more to the right. I know it looks terrible right now, but so what? It's a small little game. Minus 0.1. What's this? 0 for now. Yeah, should be fun. I hate it when that happens. Close enough. That should work. Okay, now for the actual game over. I had to swap these two around. I kind of made a mistake here. So anyway, for the title, let's look for Flappy Bird. If it is over here, the entire... Yeah, there we go. That's what I want. We want this to be underneath the title. Okay. Flappy Bird. Take it up. Make number 3. Okay. Then we just consider this to... Just press F2 and text. And the play again button, we can just drag this here. Or I could just make my life easier and just drag it in like this. That should work. Make this a bit bigger. Nice big chunky button. Play again. Okay. And if we just deactivate this, it's going to look like this. Okay. File save. Okay, now we're going to need a game manager. Tools, uNode, create new graph. But this time I want only one instance of this. So I can basically just go to class component. Yeah, class component model. And let me think here. So what we can do is we want to make basically a singleton of this. The runtime graph singleton. There we go. That's what I want. So graphs game manager. Save it. Okay, it's on awake. So this will persist basically and destroy any others that come into play if there's more than one. So we can actually do this. This is already going to be static. In the C# graph, you need to make this yourself, but the runtime graph will take this care for you with the persistence. So on awake, if instance is actually, yeah, we don't even need this with the runtime graph, but let's just do this anyway. So game manage game object instance on awake. We set the instance to this game object. We can just leave it public for now. Okay, let's also make a game. We need to reference our game object canvas now. So game over canvas. Okay, make it private. Serialized field. Okay, so awake. I need to make a couple of changes here. So if our instance equals null, then the instance equals to this. Okay. Now let us also do the game over screen. The game over function or method I'm in. Game over. Going to that. Now we basically got to set this game object canvas to active when the game is over. Set active. We want this to be true. But we also got to freeze time as well. So time scale. Set value. Let's make it 0. And we got to reset it once we're back in the game as well. So on the exit of our if, we got to do time scale and just set it back to 1 like it was. Let's set it. I have no idea why I did that. Okay, we're also going to need a restart game function. Add new function and then restart game. Okay, so now if we're trying to load a scene, we can't just do scene dot load scene without actually. Yeah, we don't have to actually. There is a namespace for it, but it's better if we add this manually. So go double click on your game manager here, open up your namespaces, then do Unity Engine dot scene management. That's all you have to do now. It's in our library. It's imported. So now if I type in here scene manager dot load scene. Load scene. Okay, yeah, I can do it like this. Yeah. And then we gotta say get active scene. This will basically reload the I have to do this differently. Scene manager load scene. We don't want the string, we want the scene, also not the build index. This requires a scene, okay. Load scene. Yeah, I guess we can do it with the build index. Be fine. Build index. Plug it in like this. That should take care of that for now. Okay, now we're gonna need our game manager game object. So create empty game manager, and we can just simply drag and drop our game manager onto the game manager. So we just need the game over canvas for the serialized field, and we reference it like this. Okay, now for the play button, we'll add an actual button to this, otherwise this is not gonna work to restart the game. The button, and so on click, we gotta reference our game manager function, singleton initializer. We got to do here basically. Okay, with a runtime component, you can't do it like this with a Unity event. We're gonna have to do something different here. So I'm gonna go back to the actual awake. Let us reference the button. You need another namespace called Unity engine.ui, and on the why didn't you save? Okay, so on this now, we got to basically make our button be subscribed to, so we can actually listen for click events. So I'm just gonna do like a button here, like Unity engine.ui button. Let's call this restart game button. I'm just gonna make this, gonna leave this private serialized field. And we want to basically listen for the on click event. So once you've dragged out the restart button, game button variable, drag this out and do on click with the button on click events. The on click, yeah. Once you've done the on click, drag this out and say set value. On set value. Hold on, I just forgot now which one it was. Add listener, yeah. There we go. Once you've done this, hook it up to the exit of the F, and we gotta do this assigned to lambda. And we can basically just drag our restart game in here. We'll load out basically our scene. So the game manager, we're not even gonna need this on click event here anymore. On the game manager, restart game button, we go play again. There we go. So if I now just enable this and press play. You see I've got a null reference exception here. Variable with name manager. That is weird. Let us quickly debug this to see what's going on here. So if I press play, okay, now it's working for some reason. I have no idea why. Okay, basically it's just very simple. You go to the game manager, and then game over. Okay, let's check. I just collide with anything. The on-collision event even fire off. On-collision enter. That's interesting. Why is not? Hold on. Okay, basically, final thing we got to do is we got to go back to our bird controller. And since this is a virtual body, we can just basically use an on-collision event for this. So we can do a game event physics. Done on collision enter 2D. Maximize this. Refresh. Here it is our method. So when we collide with anything, we just want to say game manager. Game manager instance. And then we gotta do game. And let's just do this get components. Game manager. Let's make a change to game manager. We want to say restart game. We can also maybe game manager. Well, I can't reference the thing. I think I'm doing something stupid again. Turns out this was the problem. For some reason, it wasn't even using reflection, it was using native C#. So it was out of date. So if this ever happens to you, just make sure you recompile it over here or generate the deleted script, which I'm going to do here. I'm going to keep this purely on reflection. So let's go to uNode generators. So run using native C#, so bird controller. Oh well, let's just leave it like this for now. Okay, let's play. There we go. And now froze. When I press play again, it restarts the game, but doesn't reset the time. Interesting. So we just need to reset the actual time scale quickly. So awake. It's supposed to reset it, yeah. Okay, let's check the time scale, project settings, time. Yeah, time scale set. Yeah, there we go. That was right. Okay, after some debugging, I figured out what was wrong. Could I just turn the persistence off for now on this game manager? It keeps using the reference to the script and not reinitializing the variables correctly. So if I press play now, and just I press play again, there we go. Now it's working correctly again. And that's basically Flappy Bird for you. Pretty simple to do. Okay, thank you guys. See you in the next one. Okay, that's awkward. I forgot to add this as well to reset the actual thing. Look it back up while holding shift. Okay. See now if I try and if I die, no, if I press it. It resets it, but it still does not do the timescale correctly. Very interesting.